Let's start with the problem 3, the homework. Before we start with the problem 3, the problem 1 and 2 is just asking about conjugate acid and base. Let me just give you a little bit of that. Again, I explained it in class. And a conjugate base of an acid would be minus the hydrogen. There are two things that change. Only one hydrogen less, and the charge. And the charge is 1 unit down. So those two things, the hydrogen and the charge. Example, you got HOCl, for example. So the conjugate base of the acid would be OCl. I took the hydrogen away, right? And it's going to be, you see, 1 negative more. The conjugate base of H3PO4, only one hydrogen, is H2. That's the first thing that changes. And minus 1 negative charge. The conjugate base of H2PO4 minus would be H. I took another hydrogen, PO4. So the charge changes to minus 2. Is 1 unit negative. You subtract. And of course, the conjugate base of would be minus 3. Now with the bases, it's the opposite. If you got OH hydroxide, the conjugate acid of the base would be 1 hydrogen more and plus 1. So this is for the conjugate base of an acid, and for the conjugate acid of a base, it's plus 1 hydrogen. And if you want to remember this and not forget, think about the opposite. Minus 1 hydrogen, okay? Think it's the same, minus 1. So the charge decreases 1 unit and 1 hydrogen less. With the conjugate acid, the hydrogen increase 1 hydrogen more, and the charge increases by 1. See, so minus 1 plus 1, no charge. The conjugate base of ammonium would be, ammonium would be NH4 plus. So we take a hydrogen and we do NH3. That's a conjugate base of this acid, and we take one unit charge, 0. And if we look at the opposite, NH3, the base, if we want the conjugate acid, we add a hydrogen, NH4, and the charge adds 1, increases in 1 unit. HSO4, conjugate base, take 1 hydrogen, and the charge should decrease in 1. So HSO4, charge is 0, now it's going to be negative 1. Conjugate base would be minus 1 hydrogen minus 1. So you took this hydrogen SO4 minus 1 minus 1 minus 2. Conjugate the acid of Cl negative HCl and so on. Okay, let's continue with problem 3. And it's, remember, the quantities, the numbers here are different, but the problem is the same. So we got here that what is the pH of a solution of 0.0137 molar of NaOH? NaOH, NaOH is a strong base, sodium hydroxide, and it dissociates in water in Na plus OH minus. So if you got a solution of 0.0137 molar, here you're going to have 0.0137 and the concentration of hydronium is 0.137. So the pH is the minus log of the concentration of hydronium. Okay, and with water we know there's two ways of doing it, but we know that from the ionization of water, Kw is equal to Kw, because water is a weak acid and a weak base. It's amphoteric both. H3O plus. I explained it in the prior videos. Talk a little bit about this. So, on the chapter 18 PowerPoint problems. So you got here, okay, that you got the concentration of OH. One way of doing it is asking for the pH. So how do you find the concentration of hydronium? Well, you got that you got the value of Kw1 by 10 to the negative 14. 1.0 by 10 to the negative 14, that's Kw, equals the concentration of OH. That's always true for any aqua solution. In this case, it's a basic solution, so I was saying that the OH concentration is higher, but still you have hydronium from the water. So you got this plus you got this concentration of OH. So you can find out the concentration of H3O. I put 1 because I'm going to do it this way, and I show you a different way of doing it. H would be, I put this, I'm solving for H3O, 1.0 by 10 to the minus 14. And now that is going to be divided. I divide by OH both sides, and the concentration of hydronium is hydroxide is 0.0137. So the concentration of hydronium is 7.299, 7.299, which is 7.30 by 10 I left it at 72.99. Everything that the calculations, I did all this calculation and they're perfect. Well, perfect. There's some, you know, but they all of them give me correct in the quiz. So this would be that the pH would be then equal to the minus the log of the concentration of hydronium, which is 7.30 by 10 to the or 7.299 by 10 to the negative 13. And by the way, this is M. So this is going to be, the pH is going to be 12.14. And this is a basic solution. Well, of course. The second way of doing it, I'm going to do it this way all the time, but I'm going to show you how also you can do it. And is that if you get that the concentration of hydroxide, it was 0. Here it is. 0. Is given on in the problem, right? M, you see, is given on the problem 0.0137. Okay, you can find the pOH. pOH is, because pOH is the same, is the log of the concentration of OH. pH is the minus log, of the concentration of A3O, and pOH would be the same by the concentration of hydroxide. So the pOH in this case, you have this already, would be the minus log of 0.0137, and this should give you that the pOH equals, I don't have this done, strange, but I'll do it in a second. So it's minus log of 0.0137, 1.86. So now you got that the pH plus pOH equals 14. So that means that the pH is equal to 14 minus the pOH, which is 186. So the pH equals 12.14, and it's the same thing we got on number one way of doing it. I don't know, whatever you find is easier as long as you do it right. 12.14, that doesn't make any difference. Okay, let's go with the next one. So now it's asking for the pH of 0.063 m of HNO3. HNO3 is one of the big five, which is nitric acid. And if I'm going to write down here the 100% dissociation with water. So it's going to be the concentration of hydronium plus NO3 negative. And here, all is gone. There's no concentration, there's no ice or anything. So if you got here 0.063, meaning that all this is present in ions. And this, so you're going to get here 0.063, 0.063. So that means that the concentration of H3O plus would be equal to 0.063. So the pH would be equal to 1 minus, the log of 0.063. So the pH would be 1.20. And we're going to work with this is called mantissa, the decimals in pH. And we're going to work on POH. We're going to work with on PK and PKA. We'll see. PKA or PKB. We're going to work with 2 decimals always. Okay, let's do 5. Number 5. Okay, and we got, what is the POH? What is the POH of a solution of the 0 point? This is also straightforward. Molar of KOH. KOH again is potassium hydroxide, strong base, dissociates 100% in potassium ions and OH hydroxides. So if you got 0.0577, as this is 100%, you're going to get 0.577 and OH 0.577. And so the concentration of OH negative would be 0.0577. So the problem is asking for the POH. And before I finish, sorry, I forgot. This one is a pH of 120. This is acidic. Sorry. Remember, less than 7, acid. Acidic. More than 7, basic. So here, 120, yeah. Here, let's continue with this one. And this is going to be, it's going to be basic, this one already. But let's see. Let's get the POH and see. And this is going to be minus the log of 0.0577, and it's going to be that the POH equals 1.24. If you got a lower POH, is basic. If you got a lower pH, is acidic. A lower pH is a higher POH. A lower POH, basic, a higher pH. Okay, let's go with number 6. And I know we have to be careful with that. POH. And this is a basic solution of barium hydroxide with a concentration of 2.05 molar. Let's write the dissociation because this is important as we have 2 hydroxide here. And if you remember from the first exam, chapters 12 and 13, you're going to get Ba has a charge of +2, and then you got 2 hydroxide balancing, right? So if you got here 2.05 molar, here is going to be the same at 1:1, but here is going to be twice 2.05, which is going to be 4.10. This is the concentration. So the concentration of OH negative hydroxide is going to be 4.10. And the problem is asking me for the POH. POH is equal to the minus log of 4.10 POH is equal to minus 0.61. Very basic. Okay. Extremely. Okay. What is the pOH of, and it's right. I entered the number and it gave me correct. Okay. What is the pOH of, because you're going to say, oh, she made a mistake calculating. Just double check anyway, my calculations. But the procedure, you're going to do it with your own numbers. 0. pOH of 0.00908, okay, of HCl4 perchloric acid, which is a strong acid, the big six, plus water. I'm writing the ionization now. Strong acid H3O plus ClO4 negative. And it's the same. You got 0.00908. That's the concentration of the acid. And hydronium would be the same because it's a strong acid. So the concentration of H3O would be equal to 0.0098 molar. But the problem is asking for the pOH. So we first have to calculate, first have to find the concentration of OH, and then we calculate the pOH. We solve for the pOH. You see? They're asking for the pOH. So let's start with the KW. Okay? And you know that KW is equal to the concentration of H3O plus multiplied by the concentration of hydroxide. So 1.0 by 10 to the negative 14, that's the KW, equals 0. This is the concentration of hydronium of H3 plus multiplied by the concentration of, and we're doing this because remember we need to find out the pOH. OH negative would be 1.0 by 10 to the minus 14 divided by 0.0098, and this is equal, and we take it to sig fix. This has 1.0, and this is gonna be 1. I didn't take it to 1.1 or 1.011. I did it like that and it gave me because then the pOH would be equal to the minus the log of this number of 1 of the concentration of hydronium by 10 to the negative 12. If you do it with 1.1, for example, or with 2 sig figs here, right? Rounding, you're going to get also the same answer. pOH equals 11.96. And just remember 1196, so the solution, if the pOH is high, that means that the pH is lower. So this would be an acidic solution. Okay? And HCl, is an acid. As pH plus pOH have to give you a constant value of 14, okay? Lower pH and higher pOH is acidic. If you have lower pOH and high pH, it's going to be a basic solution. And if it's 7, it's neutral. Okay. So let's go. Let me see if I cut this here, or let's go to the next one. Oh, this is the same one. I'm gonna check this out. Okay, sorry guys. This one was the 8, and the 7 is this one. Okay, and this is, oh, what happened with me? I didn't copy. Okay, 7. Okay, the 7 would be, what is the pH of? You're gonna find out, of course, a different concentration there. What is the pH? Okay, of a solution? This is the 7. Okay, and it's the solution is cesium hydroxide. Okay, dissociates in cesium plus 1 plus OH negative. I know where I jump it because this is very similar to the number 3. Oh, identical. Yeah, you can do this by yourself because again, this is 0.000. The only difference is the numbers, and this would be 0.00051, 0.51. It's still basic. This. Do it if the pH, you know how to do the pH that you're finding is more than 7, you know it's basic. And if it's less, it's acid. And number 8 would be this one where we did before, is the concentration of the acid, right, perchloric acid. You get this 100% ionized, okay, and then you find out the pH, and the problem is asking for the pOH. So you find the concentration of hydronium, right? And then like we did here, and then of the hydroxide, sorry. The A30 plus is given because it's here, is the ionization of the acid. So the concentration of H3O is given here. We find the OH, the hydroxide, and then the pOH. Is that what the problem is asking for? Like I said, number 7 was very easy, similar to the 3. I'm going to pass it because if not, okay, I can stop it now.